Hello, my name is Esther Reisinger. I am a certified Onshape associate and a lead designer on an FRC team in Boise, Idaho. Today I'm going to be giving you a beginner's guide to how to design a tube plug. Sorry if there's noise in the background, my cat is eating her dinner right now. Now, looking at this tube plug, you'll notice there are a couple different types of hole patterns on it. All of the tube holes that I'm going to be using today are 832 hole sizes. In the tubes here, you'll notice that these holes are basically tangent with the inside wall of my tube. This is a situation where if you have a part that's mounting to the tube with these holes, and the part doesn't have a lot of strain on it, that you wouldn't need a tube plug here, because the wall of the tube being so close aids in that bolt support so that there isn't as much of a likelihood to buckle or bend the tube. But here on this side of the tube, where I have these holes that are a 1/4 inch off the edge of my tube, they are not fully supported by the wall being so close. This is a situation where you would want to use a tube plug. The tube that I'm using today is a 1 inch by 2 inch tube, and the wall thickness is a 1/16. So in order to do the plug that I'm going to teach you how to design, I'm going to start by sketching on the top face of the tube. And I don't want to use these outside lines, and it may seem obvious to a lot of you, but for a few of you that haven't had much experience with 3D modeling, the tube plug goes into this section here. So if I used the length of this part and I made my plug, it wouldn't actually fit in the 7/8 size of the inside of the tube. So I'm going to start by using these inner walls in construction lines so that I can know the bounds in which my plug has to fit. The next thing I'm going to do is create a rectangle, and I want to capture this hole, this hole, this hole, and this hole, so I'm going to move my rectangle to be right above the last hole that I want to capture. Now, a good rule of thumb for material past the bolt is to use the same diameter of your bolt hole until you reach the outside of the plug or the piece of material. So I'm going to create a dimension, and if I had this hole that is 0.1695 and I want it to be that same diameter away, I'll just make it 0.17. No need for it to be super exact. Now my plug has a good length set, but the sides are way off, and I can move them wherever I want them to be, so I need to define those. Now, if I just made the rectangle the exact length and I go to print it on my 3D printer, most 3D printers have a tolerance that prints either 15 thousandths over size to 10 thousandths, 5 thousandths, and I have never seen one that prints exactly to size. So we'll want to make this plug slightly undersized, so I'm going to add roughly 5 thousandths of clearance per side from the inside of the wall. And once you finish working on your plug, you'll want to print the plug and make sure that it fits in your tube just right. So now that I have the rectangle of my plug dimensioned, I'm going to go back and I'm going to use all of the holes that I want to put in my plug as construction lines. Now, when you're first approaching a plug design task, you're going to want to observe all of the constraints that are going to be placed on your plug. So here I can look at these holes on top and be like, oh, perfect. I just have to have holes for the first 1/2 inch into my plug. But when I look around at the rest of the system, I'm going to realize that the holes actually go all the way through the plug. And since this is an 832 clearance and the top is an 832 clearance, I'm either going to have to look at the rest of whatever's bolting onto here and see if the plug needs to be tapped on both ends so that a bolt can go into one end and another bolt can come in from the other end, or if the thing that mounts to it is tapped on one side and clearance on one side, then I'll know that I need to run a bolt all the way through the system so that the plug is going to be a fully clearanced plug. Now, to keep things simple for today, I'm just going to pretend that my bolt's going to go all the way through the tube. So my hole in my plug is going to be the exact same size as it is in the tube. Alright, and here I have the general sketch for everything that my plug needs to function. Now I'm going to start by making an offset here, and I'm going to offset it by the thickness of the wall of the tube. plus those 5 thousandths that I wanted my plug to have clearance from the wall. And if I zoom in here, you'll see it offset it in the wrong direction. So I'm just going to click this and it will switch to the opposite direction of the extrude or of the starting offset. So now when we look at it, we have that 5 thousandths. Now the total distance that we're going to extrude it is going to be the height of our tube, inside to inside wall, minus the total clearance that you want. So I'm going to subtract 10 thousandths. And here we'll see we have 5 thousandths per side of clearance. And there you go. That is the very bare minimum that you need for a tube plug. Now on an FRC team, generally tube plugs are really heavy and you're always fighting weights to be able to optimize performance on your robot, but you don't want to throw away 15 pounds into printed plastic in your tubes. So here we're going to lighten this plug. I'm going to start by making a sketch on that same top face. And I'm going to go into all of my circles and I'm going to make construction circles and I'll make them all of the same size. Now, I don't want my holes to have this much printed plastic around the outside of them. That's not very supported. So I'm going to add at least 1/8 from the outside of my hole to the outside of the construction line circles that I made. Now, generally, when I'm working with a plug, I like to have the front and back of it be flat all the way. So I'm going to use those lines too. And I'll make the other 2 lines that I know I have to stay in construction line. And now I can hide my plug and work on the rest of my lightning pattern. When I start lightening a plug, I first start by drawing a line in between all of the circles. Drawing the line in between them just makes the plug stronger because I will eventually have a rib of material here to support the plug. Now what I want to do is connect all of the points that are going to be having stress in them in the most realistic and strong way. So I'm going to start by making lines that are parallel to the center lines so that I can have a solid rib of material around where my stresses are going to be. And similarly, I'll just do that for the rest of these. Alright, so I've completed the ribs between all 4 circles. But now you'll notice, why did I make this circle out of construction line when I could just make it a solid and we could extrude everything around it and it would be fine? What I've noticed in my experience is when I make this circle a solid line and I go to change my plug at all, sometimes with complex lightning patterns, and when you update the extrude, the whole thing will explode because it can't remember what exactly is confined to the inside of your solid part. So I'll start with a construction line and then I'll create a solid line just around the perimeter of my circles. But I don't like that for this situation. I would do that here on the inside. But anywhere where the hole gets close to contacting the outside of my plug, I'm going to create another little arm or little leg to go out to the wall of the tube. And this is just adding that support in your plug so that they are very well held firmly in the tube. And now I just have this remainder section that is construction line. So I'm going to go back and make that a solid line so that the whole thing is defined here. And as I was saying, I want the front end and the back end of my plug to be fully flat. So instead of just making a little arm that goes out here, I'm going to draw a line here and I'm going to bring it down, and then I'm just going to make a fillet in between these 2 edges. Make that fillet tangent and then make this a good thickness. I like a 1/4 inch thick. And down here I would just add another little line segment here. Similarly back here, I'm going to connect these, add a generous fillet here, and draw the line back here off to the tube wall. And then I'm going to connect these. And there you have it. Now, the whole purpose of creating this sketch here and defining the shape of my plug is so that I can find everything that is not necessary for the strength of this plug. And that's how I decide what I'm going to lighten. So now I'll create an extrude and go back into all of the sections that I created. And it looked like in my extrude it wouldn't let me select this section. So I must have an error. Oh, would you look at that? I forgot to make this a solid line. Now I extruded everything that I need to make my plug work. But in order to make this thing a little bit stronger, I'm just going to go around and polish every single round edge on the inside of my plug by adding a nice fillet just to make it smoother, and in my mind it adds a little bit more strength than it had previously. And I'd maybe make that fillet 0.1. Alright, now when you're putting a plug into a tube, I like to make the front end, or the end that goes into the tube first, have a nice chamfer on it, just so that it can fit in there nicely. So I'm just going to go around this leading edge and add a 0.1 inch chamfer all the way around it. And just like that, you've created a nice tube plug that you can push into this tube, and you can support all the bolts that go through here. Hopefully this gave you a little bit perspective on how to design a tube plug for an FRC team if you're a new student or someone's asking you to design you one. This is kind of the bare minimum. A lot of times you'll get uber complicated plugs, or the tube will have holes on both sides and be multi-axis, but this is a great way to get yourself understanding how to create a plug and how to lighten it and the process behind that. And thank you so much for watching. Hopefully this was helpful, and I'll see you next time.